Hey everyone, we're back online for another episode of Devs in the Sheds. I'm Matthew Coles, work at AWS over in Melbourne, Australia. Paul is in Australia with me as well, based out of Melbourne. So we're TAMs and SAs on the local teams. For the regulars, you'll know us quite well. But for any newcomers that are on the stream right now, the purpose of the show is to look through some of the AWS's new releases, get hands-on with the tools. Sometimes we dive into IoT and other bits and pieces, but the idea is, always be hands-on, creating things and finding fun projects to work on and exploring the new stuff. So with that being said, we do have a couple of announcements that I'll go through in a few seconds, but today's topic is going to be on SQS. Let us know in the chat if you've used SQS before. I'm actually super rusty, to be honest. We do episodes every single week. We fumble and we learn. So I'll probably be doing a lot of that because I haven't touched SQS for a while. Paul hadn't touched it until recently as well. He's been deep diving in a particular project, and he wanted to walk through some of the cool stuff that he'd learned. So we're gonna really dive into SQS today. Some of you guys might actually know more than us on it. Go ahead, Paul.
Yeah, it's not just SQS, but it's SNS as well. So the topic will look at both SQS and SNS and some of the features that you're unaware of that have come out. I mean, they're just less spoken about features of the services.
Yeah, no, that's exactly it. So let's dive into what's new first. I think that's a good starting point before we dive deeper into SQS. So I'm going to get my screen share up. And hopefully we don't have a mirroring effect. I'll try and be as fast as possible. Here we go. So the first thing that came out in the last week was general availability of Amazon EBS IoT block volume express volumes. As a TAM, we've spent a lot of time looking at GP3 volumes in particular. Those were a big announcement last year that saved a lot of cost. IO block express volumes are going to be more performant than that. They're going to cost a little bit more, but they're going to give you a really, really good volume VIOPS. So this is the first time I'm actually having a look at this release. A few of these are going to be a bit fresh today as well. But by the looks of it, you can have IoT volumes with up to 256,000 IOPS, which is insane actually, and 4,000 megabytes of throughput. And storage capacity of 64 TIB. Yikes. So Paul, I don't know if you've done much work recently with the IO volumes, but what's your thoughts on this particular one?
I think that when we have customers that are running specific workloads that are IO intensive, they're always looking for the best value for money. And, services and applications are growing all the time. So we still have many customers and many workloads that need either high IO for their application layer because they're doing lots of read and writes from disk, or they're running their own specific database for whatever reason. And if they're managing themselves, these are the sorts of volume stores that those customers are looking to go to. So, every time I see an announcement like this, it says, all right, we've just been able to get a little bit more, bang for our buck. And secondly, squeeze a little bit more performance out of our application.
Yeah, I know that the customers that I was working with within the banking industry prior, they would be loving this right now. So, they had ledgers and quite a number of other really IO intensive workloads that they're always pushing the boundaries with. So this will give them some breathing space. And I think the article kind of calls that out as well. Oracle, SAP HANA, SQL Server, SAS Analytics, those are some of the types of products that might take advantage of this quite massively. So I'll move on to the next one because we want to dig into SQS. But the next one that's quite exciting is we've got version 1.21 support of Kubernetes. So EKS and EKS distro now support that newer Kubernetes version. That's pretty good for customers. It means that we've now got support for 1.17, 18, 19, 20, and 21. So those are all fully supported. I know that we try and support free versions back, so I wouldn't be surprised that there might be some upgrades happening in the next couple of months where people are moving up from 1.17, which I think I've seen the majority of customers deployed on. They might be pushing up to 1.19 now or something. So yeah, actually it mentions ends of life down the bottom. So 1.17 will be end of life on October 4. But of course, I'd be expecting that people would be jumping on 1.21, and I'm sure it's got a whole bunch of new features in there, including cron jobs, immutable secrets, config maps. So yeah, there's a ton there that's brand new. So
and probably
yeah.
the jump from either 19 or 20 to 21 is probably not going to be too destructive. I know the 19 jump had some breaking changes, so they removed some deprecated APIs through that service. But I know that going from 19 to 20, I literally clicked the button and my cluster was upgraded without any faults. But I mean, like, I'm sort of running proof of concept workload, so it's not too big of a deal. But yeah, I hope people are, keeping on top of this and making sure that they are moving and migrating their clusters to the newest versions. You'd hate to be on an unsupported version.
Yeah, and Kubernetes is moving so fast as well. So I know that some teams struggle to keep on top of this. I know until recently it was like once every 3 months a major version would drop. I think that's gone back to, roughly once a year now, if I remember the release schedule. But yeah, this is quite exciting, and I'll have to dig into the new features myself and learn more about what each of these mean. Check out the article though. I might post that back in the chat, or Paul, if you want to, that'd be great as well, because we can dig into each of the new features if they're of interest to anyone.
Sure.
Now, the next one is RDS Cross Region automated backups for regional expansion. So this is a new feature by the looks of it that could be quite handy for customers that are using RDS in particular. I know that a lot of customers want to have that cross-region backup to make sure that backups are secured in multiple spaces and they can enact BCP quite fast. Looking at the regions that this does support, there's a ton. I can see Singapore and Sydney, Tokyo are called out in particular. Those are the ones that and Seoul. So and Osaka, there's a ton. So it's really good for us in the APAC region. We're really keen to have this as a new feature, and I'm sure customers will be using it. I'd expect that customers might take a little bit to pick this up over in Australia. In particular, they'll all be waiting for the Melbourne region to come out in the coming months to years or whatever it is for compliance. So yeah, it's a great feature to have. It's going to make everyone's lives a bit easier. The last one that was quite new as I rushed through all of this was there's new Java detectors and CI/CD integrations with GitHub Actions for CodeGuru. Seems like there's quite a bit of a change here, but if I scroll down halfway to the article, most of the changes were around additional security detectors for Java, so you can identify issues that might be caused by Java serverless applets and APIs and all that stuff as well, Spring. So this is going to be quite cool for customers that are using Java and want to make sure that the code is developed securely. And I guess one of my favorite things about CodeGuru is the fact that it's trained on, I think it actually mentions on the top, we don't really spell it out too often, but I thought I did see it in here, but it's trained on open source, and it's trained on hundreds of thousands of Amazon repos as well. Here it is. So you'll get some really good learnings, and Amazon repos as well, and the amount of Java that Amazon does use across its services. You're going to get very accurate and high quality suggestions for your Java code and what you can make better from an AppSec perspective. Anything to lean on? Yep.
I'll just throw it out there for the audience. Has anybody used CodeGuru? Had a look at it? Either the service itself is in determining whether you're doing best practice for security, but also there's a profile that's within CodeGuru. And just to give a quick summary of what that service entails is effectively you hook up CodeGuru to your repository, and that can be GitHub or code commit. And when you can do a full repository analysis, and it will look across your repository, look at that code, and it will look for specific security implications, best practice coding, and also looking for let's just say you opened a file pointer and you forgot to close that off, it would look for that and it would highlight those sort of areas. So what it is having a peer review on your code. And so like it's quite a useful service and can help you as an individual developer have quite a bit of confidence about the code that you're putting in before another human within the team goes ahead and does that review. So the idea is find those hard to find defects within your code or non-best practices, especially around security, and identify those really, really early before they get to production. And the profiler sits alongside and runs as an agent alongside your application in production that can look at what is happening and what is occurring in that environment, in that piece of code, and identify long-running methods where specific memory is being used really high, and also put like an actual physical, when I say an actual cost against specific methods that are being run. So if, for example, you were running a workload in Lambda, it knows the environment that you're running in Lambda, so the CPU and the memory you've allocated, the memory you've allocated to that Lambda function, and can say this method is costing you, $380 per month, for example. And that can be really useful because you can then highlight what parts of the app are expensive and what are costing a lot of money. And that can be handy to go back to the business and say, look, addressing this specific method that we think is tech debt is going to bring us a cost savings benefit across the whole application.
Yeah, I kind of also skipped over CI/CD integration with GitHub Actions, but that's quite fantastic to have. So you've got the Code Suite series of tools on the AWS side that you can integrate with your, you can have your repositories within, but being able to access GitHub's fantastic as well. I agree with Paul. I actually think that this is something that we don't have too much content around that I've seen in AWS, but it could be something that we could line up for a future episode. Let us know if this is of something of interest in the chat. Because I would actually love to play around with it and see how it rates my Python code, and maybe Paul's got some Java that we could feed into it as well.
Well, Hello Lupin has asked, is the Lambda cost analysis for all of CodeGuru or only Java? So it's probably good to clarify that at the moment CodeGuru supports Java and Python.
Yeah.
And so the Lambda cost analysis, yes, it does support Java, but it also supports Python as well. So it will put those metrics in for your application if you're running in Lambda in both Java and Python.
Yeah, and we are looking at like extending to additional languages. So based on community feedback, you'll see this extend over time. It's a relatively new service. I think it came out last year in reInvent, if I remember in particular. So we're going to see lots of development, or maybe it was the year before, but we're going to see lots of development in the CodeGuru space, as I think it helps all customers that are building, which is quite nice. So what I might do next is I'm going to give myself a refresher, and you guys can watch on what SQS is. It's been such a long time since I've used it. I think the last time I used it was in an app a year and a half ago. I think it was a JavaScript app. I can't even remember what it did, but it's been a very long time. But I know for customers that are that have got highly scalable apps, it's a day-to-day service. So I need to spend a bit more time with it altogether. But SQS essentially is a secure, durable, and available hosted queue that allows you to integrate and decouple distributed software systems and components. I know that a lot of customers get confused between, like, do I use Amazon MQ, RabbitMQ, SQS? What's the difference between SNS and this? What's the relationship with SES and this as well? So I know that if we're to dive deeper, there'll be particular times that you want to use SQS. Other times you might want to lean on Amazon MQ or Amazon MQ for Rabbit, which is a recent addition that we had there. Or you might want to use SNS or SES. Kind of to break it down first up, like let's maybe think about, like SES, so simple email service. It's going to be really about emailing people particular alerts that you might have. You might be also doing some marketing and using SES with Pinpoint, for example. So it's kind of like email communications. SNS is a bit wider than that. In terms of communication, you can use it to fire off additional services. You might tie into like push notifications or other systems to get messages out. Whereas SQS, like when I like to think about it, it's really a queue where things arrive and then you're going to ship it elsewhere. So other things are going to listen for that queue to be updated, and then they're going to enact on the information that's in that queue and then try to clear it out. So you might have, let's say you've got like a system event that fires off from the app that you've built. You want it to come into SQS. You want it to sit there ready to be processed by some other lambdas or whatever that might, do some data analytics, data processing on what's arrived in that queue, and then send it off later. I'm sure Paul can explain it better. I'm fairly cold on this. I know he's just dived into it again in the last 2 weeks. But
one of the best analogies, or one of the best examples to describe where a queue can become really useful, is think of your standard ticketing application. So let's say you want to buy the tickets to a conference. We know, and I've worked in this industry before. So if you are selling tickets to like a specific conference, you have this period where people are on the site, they're ready to buy the tickets, and at 10 a.m. ticket sales open. And what happens is like the load goes absolutely crazy at that point. And so from 10 o'clock till 10:30, load goes absolutely crazy. The tickets sell out. Let's say it's a big conference with like 100,000 tickets up for grabs. You'll have many more people on the site trying to buy those tickets than expected.
And a lot of the processing doesn't have to happen straight away as well, right? Like
that's exactly right. And so when you're buying your tickets, the most important thing is that the application itself has like locked and determined that you have a ticket and that ticket's granted for you, and that your payment goes through. Actually getting the PDF version of a ticket, or a ticket coming to you later, or the receipt, you're not so fast if that comes like immediately. You might like to know that yes, your payment is being processed, but having the actual PDF ticket being delivered to you, which is like really common in most of the ticketing solutions and platforms that we see around, we don't mind if that comes 5 minutes later or 10 minutes later, or even up to half an hour later. You know that the ticket is coming, you know that you've paid for it, you know that you owned it. So this is a really good example of where a queuing service can provide a massive amount of benefit. You can have your application focused on taking those payments, staying up to serve the content and letting people know that there are tickets available or not available at that point in time, and put all of the messages about printing, generating those PDF tickets, which typically generating and rendering like PDFs or images and barcodes on images takes some additional compute time. It's not just rendering straight up HTML. You're doing something that is producing like a binary artifact of the PDF. And so you put all those messages on a queue, and then you have some workers at the end of that queue going ahead and pulling those off. Now you can expand or grow the workers at the end of the queue so that are dealing with the messages on the queue, or you can just leave that at a small amount of workers that just process it over time. So you can think about how you want to go ahead and scale that up. But that's a really good mechanism to explain why and where a queue can be really beneficial.
Yeah, I think the other thing is, you're guaranteed that it's going to get processed somehow if you've got the listeners coming into the queue. So it does give you like good durability. You can have a piece of information passed into the queue to be processed later. That's not effectively going to be missed at all. There's two implementations, if I remember correctly. There's FIFO and standard. Yeah. So FIFO I think is going to go first in, first out. It's going to basically try and process this once, in particular, the message that's come into the queue, get it processed by whatever it is that needs to be processed or removed from the queue. Standard, I think it just, as soon as it arrives, as soon as something picks it up, it tries to feed it across, right? So sometimes you have a little bit of duplication where something might get processed twice, if I remember correctly. Correct me if I'm talking crazy, Paul. Talking from memory a year and a half ago. Yeah.
SQS is a guaranteed once delivery service. So what that means is that the service that message could exist twice. So you should be thinking about idempotent services that if they do accept that message 2 times, in the example of a ticketing application, if for whatever reason that message came into the queue twice, your ticket printing mechanism would say, have I printed this ticket for this customer before? Yes, I have. Okay, I'll discard that message because somebody else has picked it up. And so that can certainly happen.
Yeah.
Senf A asked a quick question here. How is SQS different from Amazon MQ? So do you want to answer that, Matt?
Yeah, I am not too sure because it's been such a while, but we can learn together. So let's have a look.
Well, I'll start talk about that. So when we think about SQS or Simple Queue Service, that is a completely managed solution. So, and when I mean managed, I mean more than just setting up and managing the server for you. It is completely serverless. We know nothing about the back-end operations, the patching, the maintenance, the hardware that is going on with SQS. We know that a queue exists and that we can go ahead and leverage that queue, and it has limits around what we can do with that. Whereas Amazon MQ is an implementation of either RabbitMQ or Apache MQ. And effectively, that is a managed environment. So that is setting up behind the scenes for you and managing an instance of Apache MQ or RabbitMQ. And you can go ahead and leverage those services for, typically we'd see that with more traditional or legacy software that somebody's lifted into the cloud. And we see, organizations go to SQS or SNS for more modern applications where they want that hands-off approach. So that's kind of the difference between them. Because SQS and SNS are serverless, you're not paying when you're not using it. Whereas with Apache MQ, you're paying for that service to be up and available, and you can grow and shrink that how you want. And the patching and the maintenance is completely taken care of you for Amazon, but it is not a serverless offering.
Yeah. And so I briefly did open it in the background of the console as well. So to use it, you basically create a queue. Actually, here's a good diagram. So you have producers, messages that are sent in to the queue from different services that you've built. That queue is then processed by consumers. So they'll grab that information and process based on what's needed and the type of information in there. It's quite simple to set up as well. I might, I'm going to challenge myself because it literally has been like so long since I've used in particular. But I might have a look at like doing something at the end of the session in Bodo free if we have time. So I'll get a queue set up in the background and take you guys through it. But essentially, when you create the queue, you choose whether you want standard at least once, best efforts ordering, or first in, first out delivery for your queue type. You give it a name, and then you've got configurations around delivery delays and message retention and maximum sizes. And then you'll have your access policies, and you can choose like a dead letter queue as well. So, messages that were undelivered can go into this queue, and you can determine how you want to process them. Encryption's enabled by default, but you can disable that if you want. And then, of course, you can put cost allocation tags and other tags on the service as well if you want to make sure that you track it to a particular project or department within your business, the cost, or just keep an eye on what particular app that this relates to. So that's like a super basic 101. What I might do is I'll stop sharing my screen. Yeah, go ahead, Paul.
I was just going to make a quick call out that the difference between a FIFO queue and a standard queue, like when you're interacting and implementing your solution, so your code interactions will be exactly the same, but because there's some extra compute going on, I guess, behind Amazon to make sure that that is happening in a specific order, the way you interact and deal with a FIFO queue is exactly the same as you would with a standard queue. However, be aware that when you're selecting the specific queue that you want, that if you have a requirement for FIFO queue, sure, go ahead and use it. But if you don't have that requirement or your application work around it, it is cheaper to run a standard queue. So there is an additional cost on a FIFO queue.
Yeah, that's a good call out. So do you want to cover a little bit around your journey with SQS over the last couple of weeks, Paul? I'll put your screen up. Yeah.
Put my screen up and let me know when it's up, Matt.
Yeah, it's up now.
Okay, cool. So look, I had an interesting use case with a customer that was they had a requirement to use a messaging platform. So they wanted to do like one-to-one messages. They also wanted to be able to do Fanout, which I'll discuss briefly in a second. But they had some specific requirements around persisting those messages effectively for forever, but wanting to be able to keep a copy of those messages if they needed to go and look back at what message was being sent at a point in time, and potentially the ability to go ahead and replay that message. Now, if you are interacting with let's just say a standard enterprise service bus or Apache MQ or managed Kafka, you have the ability to look back at the history, and it provides you a lot of these options. You can go ahead and replay that. You can do some filtering. You can you have some of these options that are there and are available for you. But they come at a cost. All of these things come at a cost. So if you go on your head and look to implement a specific paid for enterprise service bus, that's going to come at like a cost, both in managing the environment and secondly, like the actual licensing cost that goes along with that. So, we do have customers using like SNS and SQS for those specific requirements, like for cost reduction, for the reliability that's there, and for cost reduction. Their use case was really specific. So they said that, and I'm making arbitrary numbers up here, but they said we have a requirement to send approximately 100 million messages per year. However, 99.9% of those 100 million messages are sent in around one specific month, and that's around end of tax year. So they knew that they had a spike in and burstable workload. And they also knew that if they wanted to replay or look at those messages, typically, in almost all cases, those messages would come in and be requested to review it or to look at what was sent at that specific time within that 30 days prior to the message being sent. And why someone might want to go ahead and look at a message that was being sent, let's just say, for argument's sake, that your application pulled a message off that message queue, went ahead and started processing that. Part of the processing was inserting some data in a database or some downstream system. An exception was thrown, and try-catch caught that exception. But in the catch, we didn't tell SQS that we didn't fully process that message. We instead told SQS that we did process that message, so it's been lifted off the queue, so it won't be retried. And a second example of that might be, even if you try that over and over and over again on that queue, if that message is never processed and told that it's been processed, it'll end up in dead letter queue, and you might need to pick it up off dead letter queue and process that later. And if you didn't have anything lined up, that just might not be, there might not be a way to go ahead and look at the specific message that went through. It also might be like really useful to pick some of those messages and replay them on a new system. So this is one of the features of let's just say managed Kafka. When you say, I've built my application and I've built version 2 of my application, what I'd like to do is rerun a whole bunch of messages through that and see what comes out at the other end. Does it look the same? Does the data in the new database look the same as I expected in the old database, given that I reran through those messages? One of the interesting requirements that this customer had and this work solution had was that they were transitioning from some legacy platforms, and some of those legacy platforms needed message sizes of larger than 256K. Now, 256K is a limiting factor for both SQS and SNS. However, Amazon or AWS has provided some extended libraries around dealing with SQS and SNS, which enables messages up to 2 gigabytes in size. So
yep.
those libraries are available like on GitHub. And so, Matt, if you quickly look it up, you can maybe paste these couple of links in.
Yeah, I can look them up. I was going to say, I remember we talked a couple of weeks ago when you said you've got customers interested in sending about 2 gigs across, and I couldn't fathom what you'd want to put in a messaging queue that would be that size. So yeah, that's
it largely came from, I guess, if you've got a legacy system that is sending messages, at some point in time, you might have thought that was a good idea and it might have made sense. And yep. A large message might even be as far-fetched as moving like a base 64 encoded PDF or an image or a scan between systems. I probably wouldn't design a system like that this time. I'd have a pointer to a file or something like that. But it still is out there, and it's still it is something that obviously customers have asked us for, because we've built these specific libraries and interfaces to handle these specific requests.
Yeah, no, it's pretty cool. It was just like, wow, those are some big messages. The extended library is only for Java, isn't it? Is that right?
That's exactly right. Yeah, it is, Matt. So, which meant that as somebody that is not a Java programmer, I had to like dive back into Java and Maven and setting up IntelliJ and get a little bit used to this so that I could work through some of the solutions for this customer and for this proof of concept. And I'll show some of the Java code we did today. Effectively, what the Java library does for you is enable your application or your code, your business logic to interact with a queue as if it was a standard queue. However, you can move in and out large messages. But what happens is, and I'll probably draw through this, what is actually happening here. So if I've got my draw.io up here. So if we've got like a specific producer that is producing a message, and that message is going onto that queue, but that message is 2 gigs, right? So let's say we've got a message, or even if let's just say it's a 10 meg message.
Yeah.
Now, if that message is 10 meg, like we know that SQS can't handle that for us. So the Java library, and if we, the Java library there is, I'll just pick any one of these libraries here. I'll pick JavaScript, but don't worry. So what happens is the Java library, extended Java library, sits in front of like SQS or your interface within your Java code and says, oh, you've got a message that's 10 meg. What should we do to go ahead and handle this, given that this platform here only handles messages that are 256K? What it does is simply takes that message and writes the body of the message or the main piece of the message into S3. So it goes ahead and writes the bulk of that message into S3 and then makes the call directly into like SQS. So the flow is kind of like this. So 1 to the SDK. The SDK realizes that message is large. It'll store the body of that message in S3. So we define a bucket that we're going to use as effectively a temporary storage space. And then it will tell SQS that, here's a message, and there'll be some metadata that exists in that message that is pointing to the body of the actual message itself. So when a consumer exists on the receiving side here, what that does is says, okay, well, I'm going to be polling like SQS, or if it was polling the SQS here. When I get that message, it says, oh, okay, like I'm aware that now that message exists for me, and I need to go ahead and process it. But because I'm using that extended library, it will go ahead and retrieve the body of the message from S3, as well as the metadata from, that is told that everything that needs to tell it's like, the time that it's coming through, etc. And pull that body back out into your application. So application then has access to these large messages, but effectively all of those SDKs are doing just an abstraction over moving the message or the body of the message in and out of S3. So what that really means is this SDK, and if you go ahead and look at that, because that's open source, so you can go ahead and look through that, it's basically handling putting the message in and out of S3 in a secure manner. So you don't have to worry about what is happening there, what is going on behind the scenes. But that does mean that if, like, let's just say, and I saw the icon earlier, if you were using Python and you really wanted to do it in Python, it's like perfectly feasible to go ahead and implement exactly what the SDK has done. So if you did have to redo it, you could just follow the same pattern, and you could go ahead and build that manually yourself. The SDK that AWS provides just means we don't have to do some of that heavy lifting. Yeah,
it's just kind of like abstracted away a little bit. So you could have like a particular I don't know, like let's say you could have a particular phrase or word that you use in Bodo Free for messages that are going to be over 10 megs in size, and you check that, right? So then once that's detected, you can then use it to basically say, hey, I need to upload this item to S3. And then on the consumer side, it's like, hey, I recognize this phrase in the header or whatever it is. I need to go here to pick this up from S3. Yep. So yeah, that's pretty simple, but it makes it a lot cleaner. I hadn't realized you could do this with other SDKs, but it makes perfect sense.
Yep. So as I mentioned, as part of that specific requirement the customer had, they wanted the ability to do like one-to-one or one-to-many messages. So they wanted a fan-out ability. So For anybody in the audience that has not used or not understand the concept of Fanout or not used SNS for this specific use case, Fanout means that you have like many subscribers, so many different applications that might be listening off the back of that topic. And a good example of that might be if we take that ticketing application, that ticketing analogy there, we might have a mechanism that says our application has gone ahead and said, yes, we've registered and we've paid for the ticket, and we're going to send out 3 messages. So we want to display quickly back to the user, yes, your payment has been processed, but we're going to go ahead and like enter a message, and that message might say, go ahead and print me the ticket, and we've got an application that's doing let's just say the ticket printing. A second message might be sent to another service that is listening off the back, that is, let's say, sending an SMS notification with some information about the event so that people can get really hyped up with what's happening there. And the third one might be like again, something similar to the ticket, but like, let's just say, like call that like printing the receipt. And so that might have to, for whatever reason, interact with the payment provider to go ahead and get that information. And so here's a really good example of like what we talk about when we think about Fanout. If I've published a message once, I have 3 separate applications that need to go ahead and pick up that message and process it. Now, this mechanism still works with the way we're publishing through. And if in this example, we'll just say, for argument's sake, there was a large message, and for this fictitious application, let's just say that for whatever reason, everybody had to upload a 10 meg photo of themselves, and we wanted to pass that photo around everywhere and embed it in there. So we have this requirement where we've got this specific photo that exists, and let's just say it's base 64 encoded in the body of the message. Mm-hmm. We've published that, and that has gone and sits in S3 as a specific message. SNS has fanned out the notification to all these other specific topics, but SNS and SQS both understand that messages can be and exist within the S3 bucket. Now, if we think about what the abstracted library might do for us, and let's just say this ticket print one. Now, typically when we say to like our services listening here for events that are coming on or messages that are coming onto the queue, we pick up a message, we go ahead and we process the message, and we do the processing around that. And if everything goes well, at the end of our processing, we tell the queue that that message is okay to go ahead and delete. I've done what needed to be done on that message. Go ahead and remove it from the queue so nobody else goes ahead and picks it up later. Now, if we're using the extended library to go ahead and handle that interaction, that can, depending on what you want, depending on your settings, can go ahead and delete that file out of the S3 bucket if you want to. So it can go ahead and handle all that for you, but that can be provides a real challenge when we think about some other service that needs access to that specific file. So how would we recommend going ahead and handling that situation? Is there's a default option to say don't delete the temporary body out of S3, leave it there. But then we can say what we would do to handle that is we would put a lifecycle policy on that specific bucket that says all of the messages that exist within that bucket here, we're just going to purge at the end of the month, and we're just going to go ahead and delete all of those. Now, to show what this sort of setup looks like, I've built the very first piece, which says let's go ahead and implement the ability to send a large message into SNS. That SNS, this specific implementation will put that image into S3. But this specific customer also wanted a copy of those messages kept forever, and it wanted the ability to look through those specific files, to have some organization around it and some structure with what they were doing. And so every single message that was to go through, they didn't just want to keep in an unordered fashion that was like referenced by a UUID. I'll show exactly what the standard message looks like. They wanted some extensions on top of that solution. So what we ended up coming up with was a bit of a solution that said one of the consumers or one of the subscribers to the topics that they were going to listen to was a Lambda function. That Lambda function happened to be written in Python and was using Boto. And that had a second bucket, and that was called effectively that was a bunker. And so every single message that was being written in was being collected and stored in a bucket. That bucket then had a specific structure about the day and the times that those messages were coming through, and stored that as a raw format within S3. And you can go ahead and then look for those specific messages and pull them out if you needed to do that later. Now, at this point here, I'm going to show the application how that works and what it looks like within Java, but also in the console, we can go ahead and look at the messages or the raw messages that exist within that S3 bucket. So I'll jump across to the application that I've got. So here it is here. And by the way, this is available on Maven. There's the extended libraries that are available in Maven. So if we look in our POM file, for anybody that's familiar with Java, we will find that here we go. So there's a dependency on the Amazon SNS extended client. There isn't a whole lot of information or documentation around there out there, but make sure when you're looking through Maven that you do pick the latest version. There were some issues with version 1, and some of the documentation online is still referencing version 1, so don't make sure you are using 1.1.1 or the latest at the time when you're going ahead and reviewing that. Now, if we look at the actual code here, and Matt, is it large enough to see?
I think I can read it, but I reckon one more increase in size could help people with smaller monitors.
Okay, because I'm running this inside, there's the zoom here.
Control plus doesn't work, or
it's not working because it's not carrying the key combination across, because I'm running an Linux workspace.
Yeah.
Doesn't matter. If you find it,
I think we can make do. I can read it fairly clearly, and I've got a small view on the big screen of it. So
yeah,
call out in the chat if otherwise, and we can look at it for a second. But I think it's okay.
I'll speak through it if we have a problem.
Yeah.
But if we think about what is required to put a message on an SNS topic, really it comes down to implementing the specific library, whichever language you're using, and the topic ARN. So I've created a specific topic, and that topic has existed within my AWS console. So I'll go ahead and I'll show that.
Mm-hmm.
If we go to SNS, we see that I have one topic available, and I've called that the large message topic. So I've built that with a SAM template, and we can share the code later for this that goes ahead and deploys this. And this topic, when I go ahead and deploy that, has also deployed the other pieces of the application as well. So if I go back to here, so I've deployed this specific SNS topic. I've deployed the Lambda function and that Boto library, and I'll step through that in a second. It's created the bucket, the temporary bucket that we need to store those messages as they come through. But it's also created a secondary bucket, which we've identified as the bunker bucket. So the moment any interactions happen with this queue, we know that there's a subscription of that Lambda function. That Lambda function is going to take a copy of that message and move it across into this long-lasting bucket. So if I go back to the console, we can see here it is. So we have our subscription to that specific Lambda function, and we can see I've called that the bunker function there. Interestingly, when you go ahead and you look at what is required for implementing SNS and using the large message types, there is nothing that is identifying when you've gone ahead and you've built that is saying that this specific SNS topic is of large size. So for all intents and purposes, this topic is no different to any other topic when we go ahead and we create that. It is simply passing messages through, and the abstraction exists within the SDK as it moves through, the specific event pipeline that we're looking at. Now, if we go ahead and have a look, go and step through the code, we can see that what I did here was make, I exposed this and built this as a Lambda function, so as an API. But thinking about how I go ahead and build a really large function that's going to be 5 meg or post that in, I didn't really want to do that. So I basically made a massive string, and I padded out the string to be 30,000 characters. So I'm going to forcefully send really large messages all the way through the pipeline. But here's a really good example of what the message that we're going to go ahead and send through. So I've used this JSON object library to go ahead and build something that's going to be a JSON message that I'm going to send all the way through my event system. As part of the objects that I'm going to go put into that message that I'm going to send through is I'm sending the bucket name, the topic ARN, the message, and I'll show that in just a second in Postman, a really long string, which I've generated up here, which is just like 30,000 ends, and the receive time, so the time that this application got. Now, if we look at the actual work that's being done to send that message into the queue, we see here is we define and create that SNS extended client configuration. That requires it is linked to an S3 client, which is like the bucket name. So we don't have to do anything other than effectively provide an instance of an S3 client in our specific code and a bucket name. When we go ahead and we set that up, we see that in Java, we go ahead and we instantiate that with that specific set of configuration. So all of this is almost identical if we're using straight SNS. And when we go ahead and publish that message, we can see that I'm saying for my SNS extended client, my instance of that specific library, all I'm going to go ahead and do is publish a message onto that topic ARN. I'm going to pass in that specific message and the attributes around that as well. So nothing here is, am I dealing with S3 by like uploading files, handling the try-catch around uploading a file into S3, looking at like what's the mechanism to like either should I pre-sign the put URL that I'm going to go ahead and put in. We just know that that's being handled for us. And in this instance, we can see that like, this, I think it's 30,000 characters was about 3 meg. So we end up with a 3 meg image being pushed all the way in. So what else I'll do is I'll show that. So if I take this, which I've deployed this specific API into Lambda, and we'll take a message. So I'll say, hello dev shed, SNS large message. Now I'm gonna push this message onto the queue. I haven't ran this function for a little while. I've actually only run it once. So there was some cold start. Obviously running Java and Lambda, you incur some cold start to start up the application. But we can see here that what has happened was we created a message on the back end. Here are all the pieces. The user message was like this custom piece that I passed through, and the faked long piece of message was just like thousands and thousands of the letter N all the way through. And I specifically trimmed that off in the back end so that we don't get a large response coming back. So I think that message was 300K actually, not 3 meg. So what does that look like in our application? So if we go to S3 and we'll have a look at the buckets. So if I've got this bucket that says here are the messages that I've pushed into that specific bucket. Now you can see that when I set this up, there was one message yesterday, but we can see the message that I sent just now. So this comes as like a UUID in that specific bucket. Now nobody has picked up or processed this message, so that exists sitting in that topic, and there's the only subscriber of that topic happens to be that Lambda function that's listening. But if we were to take this file and download that file, I'll save it. And if I go to, let's just say to VS Code, I'm going to say open file, and that will be my downloads. Here we go. So if we look at that inside that file, we can see that that is an exact copy or an exact representation of that, that specific message. So we know that this message, this is what is being written. The whole message itself is being written to S3, and the extended libraries are going to pick this message up and use it in and out of S3 as if it was a normal message being sent through the message bus. But what's happened in addition to that is that because I had a secondary subscriber, which was that Lambda function, that Lambda function has taken that that specific message that's come through. It has looked at the payload of the message that has the metadata around where and what that file was, and it's gone ahead and created in this bunker bucket the ability, like a little bit more convention around persisting that message for a long period of time. And so what that means is now we have like a date stamp, like as a folder, and then like a timestamp, because we want to be able to like navigate through this quickly if we needed to. And then it's gone ahead and like place that message into a bucket. So place that message into that that subset of folders within that bucket, which means that like all of our messages are available here if we want to go ahead and pick them up to do some reporting or to look over that later. Now, I know that we won't have enough time to go through it today, but the solution also had the ability to for this specific customer was, and if I go back to our diagram here, they wanted to be able to say, how can we go ahead and query out of this bucket, where our message was, like specific items for that message. And that might be look for a message with a user message that says, boats are green or something like that. So some specific information that we want to filter through. So because S3 is, I guess, indexable by when you have JSON or Parquet or CSV files, we implemented Athena on top of that. So we wanted to use Athena to be able to query directly into that JSON. And what I did do there, or what we did do, is we used Glue. So we used Glue and a crawler in Glue to crawl through, the specific properties of those JSON files. Glue was able to build us like a schema and effectively build a database that looked like a relational database around the messages and the attributes that were in those messages. And what we could do then with Athena was directly query and place queries onto those messages within S3. So we could say, find me all messages that were sent between 1 a.m. and 1:15 a.m. on the 25th of July, 2020, for argument's sake. And that would bring back a whole list of those messages that are available to you. And then you could go ahead and do whatever processing you want to do later. And that might be simply like you want to double check that something has gone through and how that might work. Now, to make that a little more consumable for some of the operations people, we implemented some Quicksight dashboards on top of that as well.
Yeah, just to visualize. Yep.
Yeah, so we had some visualization with Quicksight. And that was able for quick operations to be able to scan through that data and have a look at what might have gone wrong. And when we think about like the complexity of the solution here, if we had only like 1 in a million requests having to like looked at or replayed potentially, we're only looking for a solution that is going to address maybe 100 times per year. So this solution is going to be looked at, like, let's just say 100 times per year. And so if you had like, this specific person going ahead and saying, well, I now have like a dashboard that enables me to filter through my messages to look at those. I have all the compliance and regulation in place. So I do have the ability to keep these objects forever. I know that my message, I'm probably, in almost all cases, the message is going to be for the last 30 days. So only the 30 days am I going to be looking through. Everything that we're looking at here on this solution for this specific customer comes it's completely serverless. You're not paying some ongoing cost to keep this running all of the time. When you're running those queries across Athena, you're going to pay for the query that you're executing on that data at that point in time. And if we think about like a standard ESB, this whole solution is like almost built in, but doesn't have as many of our specific pieces grouped together to produce that functionality. What this is you'd be paying a cost that would be in licensing fee, and as well as like maintenance and uptime of the platform itself. So this is a really good solution to be able to like have the ability to look at the history of those messages and keep them forever, because we know that SNS and SQS doesn't persist those messages forever. We know out of the box that SNS and SQS don't support messages greater than 256K. This solution goes ahead and does that. Even if we have like multiple specific subscribers off the back of that, we have the ability to put that in place. And because that was all written, like I wrote both pieces in Java, but what we did do is, because we know how this works, we can look at the specific body that is being come through as the metadata. And if we didn't like using Java for whatever reason, we could go ahead and rebuild that our own way. So we know that effectively the message just has a pointer to that object in S3 anyway. So we can pick that off and go ahead and process that ourselves. So your code itself might say, okay, I've looked at the incoming metadata. It's a pointer to a file in S3. I'm much more comfortable with Boto3. So what I'll do is I'll just open that file as a consumer. I'll reach into S3. I'll set up the missions and manage the missions myself. I'll set up the interactions and manage them myself, because I know that the message body itself, I'm much more prepared to process within Python. So you do have that flexibility to go ahead and do that at the other side. Now, I did build up a little example so we can make sure that this goes all the way through. I built a consumer on the other end. So here's the example of a Spring Boot application that I containerized this application. And effectively at the other end, this is one consumer that exists. Now I set up that consumer, and I'll just quickly show that in so I've set that up in, I think I set that up in Tokyo.
Cool. And speaking of Bodo free and comfortable with Python, I haven't touched Java in years, but as you've been talking, I actually did create a message directly in the console, and then I went to the Bodo free documentation. I actually managed to receive that message as well. So it's pretty cool. If we have enough time, I can quickly screen share that. But yeah, I've been playing with it in the background, considering I need to level up here.
Well, I'm not 100% sure if this is going to work, because I think I set this up wrong here. But if it does work, I'll be able to demonstrate running this application that is pulling those large messages off the queue. I'll see if this works. It may not, because I think I changed the credentials here, and I might have to stop screen sharing for a sec to swap the credentials back. But we'll see if that works anyway. Yep. So I had this container.
Local government, local host.
I think this is going to fail. Yeah, the credentials are there. Stop screen sharing for a minute, Matt, and let me swap those.
Yeah, what I'll do is I'll very quickly give everyone a quick peek at what I did in the background while we wait. As I said, total noob. I'm confident admitting that. Effectively, I showed before how to create a queue. Very basically, I just set one up called basic SQS for dev sheds. On the right-hand side, I can send and receive some messages. So I just went in and I just went message 1, and I submitted that message to the SQS queue. I did message 2. Let's go 3, maybe 4 and 5. And so you can see these stack up in the queue underneath. So I can hit the poll for messages button, and that's going to poll, and it's just snatched the fact that I've got 5 messages. So messages 1, 2, 3, 4, 5. So they're all in the queue. I can check the payload. I can see the contents, the size of the message, the body, any of the attributes that I might have mapped. But they're all sitting there. And then I just went to the Bodo free documentation, and it was actually pretty fleshed out already. So to receive and delete messages from a queue, this is the code that's needed. So I copied that into VS Code, nice and simple. I clear my console, but I copied it in there. I grabbed the URL. It's not coming up, is it?
Yeah, you did. I didn't think you shared your screen.
I might have just done the
browser. You did.
Oh, okay.
Yeah, there must have been some glitch of mine, sorry.
That's okay. So I've got VS Code open here. All that I did is I grabbed the queue URL, which I found back in SQS. If I go back a step, I could find it just here in the console. And this is the code that I need to execute. So I just called the file in Python. And you can see that I received message 3 first. So first in, first out is going to order the queue 1, 2, 3, 4, 5, like how I created it. But using the cheaper option, it just grabs each one in the queue. And you can see it's grabbed 5, 1, 2, and then if I keep polling the queue as well, so I just go back into that screen where I was polling it, you can see the messages are getting pulled out. So I've just called it 4 times. There's only 1 left in the queue, and if I do that final call, it could be cleared already, but I'd see that final message empty out as well. So very nice and quick. Someone that hasn't used it for 2 years basically knows nothing on it. It was actually pretty easy to get up and running.
I switched those credentials around, Matt, so if you want to go ahead and share my screen.
Yeah, I've just popped you up again. Yep.
Okay, so what I've done is we'll make I'll send another message. So we'll just make sure that we've got message 2 there.
Okay.
And so here's that specific application that is At the other end, this is a Java application, and every time I invoke this specific endpoint, I've Dockerized that container, so there might be a cron job running on top of that within the container that does that to poll for messages. This is specifically looking to that queue. So here's the other side of that, which is saying I put some messages in there, so we'll see that message 2 come up in just a second. So here we go. So we can see that message 2 has come up for the the long text. We can see there's just all these ends that are just coming in there, and we can see all that information being pumped through. So there's the end-to-end setting this piece up, and what's going on behind the scenes seems like it doesn't seem like there's a whole lot of moving places, but to handle that yourself would require some extra thought around what you're going ahead and implementing. So I think the extended libraries for both SQS and SNS are really beneficial. And just quickly before we finish up today, I will show what this looks like to receive the message, so to pull the message off the queue. And here it is here. So we've created an S3 client that is required for the extended library to configure. But we have done nothing other than provide the right permissions to this specific service that's being run. The URL to the specific queue that we're going to receive messages from. But nowhere in here are we connecting to S3 or doing anything around S3 other than setting up that client. So it is handling all those requests for us. And we can see here, this is effectively the call. It's saying receive messages off that queue. This is the interaction, and this is exactly the way we would expect to interact with a message queue. And to be able to pull message off that message, we don't want to deal with all this abstraction of moving messages in and out of S3. So we can see that those extended libraries are really helpful and take away that undifferentiated heavy lifting of having to manage both or either a more traditional message bus platform Apache MQ or Kafka or IBM MQ or something like that would enable you to have these large messages, but do that in a completely serverless manner with the abstraction in front of that. And then the abstraction exists within the code. So there are ways to it's really nice to see the way that our services step together as those building blocks to reproduce some of that functionality that our customers are continually asking for to drive costs down and drive flexibility up. So, it's been helpful for those customers to think about them taking existing legacy applications that they can't yet refactor down to small message types, but have some solutions around those and some native and serverless solutions around progressively moving that application and modernizing that application stack.
Yeah, nice. And I think maybe one note to end on, I know that we've run a little bit over, but Daryl Duck asked in the chat, what would you look to use SQS for? These days, I haven't used it for 2 years because I've been so involved in using AppSync, and yeah, there we go. There's the comment. I've been using AppSync, and I've been doing a whole bunch of real-time messaging, and I've got subscriptions, pub subs set up, on those types of projects. And so I don't really have the need to use SQS myself, which is why I need to update my knowledge a little bit in this area. But I guess larger organizations or large customers that have volumes that us mere models can't understand ourselves, they would look to use SQS to help them manage just huge volumes of traffic at once, and then they can process them bit by bit as the services free up as well. So it's really critical for large scale microservices architectures. It becomes really, really super important once you get a cluster of microservices up and running in production more than anything else. But if you're just building a web application with a front end and a bit of a back end, and you're doing real-time chat or something like I've been doing, you don't need SQS. It's for those large scale microservices type use cases.
I think that we still find that making sure there's still a lot of smaller customers that are using it for that exact use case that we said earlier, trickle through processing that happens at the other end. So the ability to slow down hammering some of those backend services that have computationally expensive processing. So if you don't have the capability to auto scale up your environment, but you just want to slow it down, you don't mind if it happens in an eventual consistent manner. So that's where we see a lot of use case around this. So I would probably counter your comment that large customers use this with large workloads. I think I see a really good spread across my customers all the way through, from the enterprise that are using, let's just say billions or hundreds of millions of requests to SQS, to even smaller customers that are doing it on a small service, because it does provide you with that mechanism to break down your application into smaller pieces and smaller chunks, and build out like event-driven architecture.
Yeah, and I think I did see like why use SQS when you've got SNS pop up as well. I think we covered a little bit about that just beforehand, but I think Helpline's got the perfect answer there as well. So SQS is message persistence. SNS is just a notification, hey, I've got something here for you to process, and then it disappears. You don't have that queue engine that's going to have it sit there until it's ready to be collected. Yeah, so good call out.
Yep.
Perfect. Now, I know we're over time. Next week, we're going to look at Lambda Workflow Studio. I'm really excited to play with that. So I'll be hopefully presenting that on Wednesday, unless Paul gets excited and we flip a coin to work out who's doing it. But yeah, enjoy the rest of your week. We are doing some impromptu streams on the twitch.tv/devs in the shed channel, as well as on our YouTube as well. So these impromptu streams are going to be around Pygame this week. There's a game jam going on. So Aaron, who you might have seen on Amazon Location with us a few weeks ago, he's joined in. And we're going to stream in some of the evenings on the more unofficial channels, which will just be nice and fun. So if you want to see some Python, you want to see a fun Pygame game project, maybe we'll make a platformer, maybe we'll make a side-scrolling shooter or something, you can catch us there. But if you just want to stay for the AWS content, we'll be back on the same time next week, Wednesday, 12 p.m. AEST. Thanks, everyone, for watching. And yeah, we'll leave you on with your days. Thank you, everyone.
Yeah, hit us up on LinkedIn or YouTube, our YouTube channel where the videos go to at the end. If you've got any like questions or any follow-ups or anything you'd like us to dive into, we're always open to suggestions.
Yeah, any suggestions always helpful. We've got one for Redshift coming up. Someone in the audience asked a few weeks ago, so we're scheduling that in. And we'll catch you all later. Thanks, everyone.